Alright, what's up guys? In this video we're going to pick up with some calculus here. This is going to be another integration practice video, and this will be example number 17. So we're going to work on this one. Alright, so we're asked to evaluate the integral here, t times e to the square root of t dt. So I think the best thing to do here is to start with just a simple u substitution. We can pick u to be obviously the square root of t. We differentiate that. Remember, that's just 1 over 2 multiplied by the square root of t multiplied by dt. And if we solve for dt, we'll get 2 times the square root of t. Du is equal to dt. So what we'll have is e to the u multiplied by t times 2u du. Now, we do see a little bit of a problem. We have this t in here, and we need everything in terms of u, but luckily, we can fix that, because remember that our substitution was u was equal to the square root of t. Well, if we want to convert t in terms of u, let's just square both sides of this. So if we square both sides of that, we'll get u squared is equal to t, or t is equal to u squared, which means that we would have a u squared in there in addition to this u. So u squared times u is u cubed. I'm going to pull out that 2 because it's a constant. And so essentially what we end up with now is the integral u cubed times e to the u du. Now hopefully you see we need to apply integration by parts because we have a product of functions here, 2 different functions that is. Remember, that's the integral of u dv is equal to uv minus the integral of v du. And if you notice here, we have u to the third times e to the u du. Notice that we're going to have to apply integration by parts 3 times, because every single time that we apply it, it's going to drop the power of the u. So once we do it one time, it'll drop the power of the u down to u squared. We do it again, it'll drop it down to a u, and then we'll have to do it again. This integral is probably a good candidate for tabular integration, but I'm going to do it the long way. So let's determine what our u is and dv is. And again, this one isn't hard, it's just a bit lengthy. So let's pick u to be u cubed, and then that means that dv will be everything else. So dv will be e to the u du. So that means that du is 3u squared. Okay. If we obviously do everything. And then v is the antiderivative of dv, so that's going to be the antiderivative of e to the u du, which we know is e to the u. So we now got our 2 on the outside there. Okay. And what we'll have is u cubed multiplied by e to the u. I'm going to pull out a 3. And then I'm going to integrate u squared times e to the u du. So now the integral that we're left dealing with now is the integral of u squared times e to the u du. And as you can see, we'll apply integration by parts again. So if we do it again, we'll have u is u squared, dv is e to the u du. Same process, du is 2u du. And then v is the antiderivative of dv, so that's the antiderivative of e to the u du, which is e to the u. Okay, well, we continue essentially with the process here. Take it from there. So remember, we pulled the 3 out initially. So now this becomes u squared times e to the u. I'm going to pull out the 2, and now we're just left to integrate u times e to the u du. So now what we're dealing with is the integral of u times e to the u du. And we'll apply integration by parts one more time, selecting u to be u, and then dv will be e to the u du. So du is du, and v is the antiderivative of dv. So that's the antiderivative of e to the u du, which we know is simply e to the u. And as we continue, Yeah, not hard, just a bit lengthy. All right, so as we continue, if we do our integration by parts, we know we're just going to have to end up integrating e to the u again, which is the antiderivative e to the u is e to the u. So essentially, what you'll get after, we initially pulled the 2 out, remember? So we get e to the u multiplied by u minus e to the u. Okay. Now all I have to do is to go back to the first by parts that I had, which was up here, go to our second one, and then go down to the one that I just did and kind of combine everything. So what we'll have is 2 times u cubed times e to the u minus 3 u squared times e to the u. Remember, I pulled out a 2, and then that'll be times e to the u multiplied by u minus e to the u. Okay. So when I go back and I put everything together, this is where I arrive at. Now all we have to do is put the u back in there. So remember that u was the square root of t. So what we'll have is remember the square root of t raised to the 3rd power. We can essentially just write that as t raised to the 3 over 2, because we know that the square root of t, we could write that as t raised to the 1/2. So I'm going to move the e to the front. So this will be e to the square root of t raised to the 3 over 2. Then we'll subtract that from 3 times. Well, we're going to have to put the square root of t back in. Remember, the square root of t squared is just t, so this becomes t. This will be minus 2. And then we'll have e to the square root of t multiplied by the square root of t minus e to the square root of t. So this is what we get when we put everything back in. And I'm going to expand everything out and add a plus c, and that'll be our answer. So our final answer for this one we're asked to integrate te to the square root of t dt. And I'm going to expand everything out. So I'm going to write my answer as 2e to the square root of t multiplied by t raised to the 3 over 2. And then this will be minus 6 e to the square root of t multiplied by t plus 12 e to the square root of t multiplied by the square root of t, and then this will be minus 12 e to the square root of t, and then I'll add a plus c, and that would be my answer. So that's how you solve it. So that's the long way to do it. Now there is another way to do certain integrals without having to apply integration by parts for multiple times. You can use what's known as tabular integration. The problem with tabular integration, it doesn't work all the time, whereas with integration by parts, regardless of how long the problem it is, it will always work. You can't use tabular integration whenever you want to. Specifically for tabular integration, it's basically when you do those little columns or whatever. But the thing about tabular integration is when you select your u, you need to make sure that when you're taking respective derivatives of that u, you can get down to 0. Because if you can't, well, then you can't use tabular integration, or you need to swap your u and your dv pick and see if you continue to take respective derivatives if you get down to 0. That's the only way tabular integration would actually work. So if you can't do that, then you can't use tabular integration, and you'll have to do it the long way. All right, so if you got any questions, let me know. I'll see you next time.